Good morning. Pause the video and play when you're ready to go through the answers. Okay, so 3/8 of 136. Well, that's just means multiply in math. So 3/8 multiplied by 136. So we just need to do 136 divided by 8 multiplied by 3, which gives us 51. Now, if you're rationalizing this, you need to multiply it by 2 minus root 7 over 2 minus root 7. Now, the numerator is just going to be 6 minus 3 root 7, making sure that you're multiplying all of it out. And the bottom is a difference of 2 squares. So we've got 2 plus root 7 multiplied by 2 minus root 7, which is going to give us, these ones are going to cancel out because you've got 2 root 7 minus 2 root 7. Root 7 multiplied by root 7 is 7, so that's going to give us negative 7. So 4 subtract negative 7 is negative 3. Now here you can divide them. So 6 divided by negative 3 is negative 2. Negative 3 divided by negative 3 is positive 1. So it's going to be plus 1 root 7. So it's negative 2 plus root 7. Now this one here, we've got a non-right angle triangle. We have not got a side and its opposite angle, so we're going to have to use the cosine rule. So a squared equals b squared plus c squared minus 2bc cos of a. The angle that we've got must be a. B and c doesn't really make a difference, okay? But remember, capital letters are for the angles. So then we just need to substitute this in. So x squared equals 12 squared plus 18 squared minus 12 times 18 times cos of 40. So x squared, if I just type that in, 12 squared plus 18 squared minus 12 times, have I made a mistake there? I think I've made a mistake. So it's minus 2 times b times c. So I think I missed out the 2. So 12 squared plus 18 squared minus 2 times b times c times cos of the angle. If I've done that correctly, you should get x squared equals 137 point something. I'm not going to round there. I'm going to round at the end. So I can just do square root of my answer. And now I can round. So I'm going to say, well, it's 11.7 centimeters to 1 decimal. Now this question here, does it factorize? I don't think it does factorize, so you're going to need to use the quadratic formula. So x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. A is the number in front of x squared, which is 1. B is the number in front of x, which is 7. And c is the number on the end here. So then we just need to substitute that in. X equals minus 7 plus or minus b squared minus 4 times a times c. And look, I'm putting brackets around all of these just to make it easier to put into the calculator. 2 times a. And then I'm just going to type that exactly as I've written, including the brackets. So we've got minus 7 plus the square root of 7 squared minus 4 times 1 times 2 divided by 2. And I'm going to put it as decimals. You could put it as a third, but I'm going to say, well, that is going to be minus 0.3 to 1 decimal place. And I could just use the cursors on my calculator. So where it was plus the square root, I'm now going to change that to negative. And it's going to be minus 0.3 to 1 decimal place, or minus 6.7 to 1 decimal place. So if it doesn't factorize, just go straight into using the quadratic formula. Okay, today's title is circle theorem, so it's probably a brand new topic. Pause the video, play when you're ready to go through the examples. Okay, now circle theorems, you just need to learn lots of rules for them. Okay, so I'm going to go through each rule at a time. You need to make sure these are copied into your books and you need to go away and learn them in turn, so each one is not that difficult. The hard thing is when they're all jumbled up and you've got to remember all of them. So the first one that I'd like you to write down The angle in a semicircle is a right angle. If you have a semicircle, if this here is the diameter, any angle in a semicircle is a right angle. Okay, that's important for you to know. So I've just got an example underneath. This is the diameter here. How do you work out what x is? Well, you need to know that the circle theorem states that this is 90 degrees. And you would always have to write the reason. So angle in a semicircle is right angle. So then we've got 52 add 90, which is 142. 180 subtract 142 is going to give us 38. So angle x is 38 degrees. But just like in parallel lines where you have to write the reason out in full, you have to do the same for circle theorems. So copy that one out. And then number 2, if you've got a tangent, so where the line only just touches the circle, and you've got a radius, that meets at 90 degrees. So a tangent and a radius meet at 90 degrees. So here, if you've got a tangent and you've got the radius, you know that the whole thing must be 90. So if that's 49, this one, if I've got my maths mixed up, so that one is going to be 41. So this angle here is going to be 41 degrees. But again, you must write the reason down. So make sure both of those are copied down before we move on. Okay, the third one, put simply, if you've got your centre and you've got 2 radii, because they are radii, they're just the same length. Okay, so if they're the same length, you must realise that they're just isosceles triangles. In this example here, that's a radius, that's a radius. Therefore, if that's k, that's k, because it's just an isosceles triangle. So if I rewrote that, if I said, okay, right, well, here's a triangle, that's 98, work out what k is, that would just be straightforward. So you're going to do 180 subtract 98, which is 82, and then you're going to halve 82 to work out that each angle must be 41. Okay, so you need to copy that one down. Now this one's a bit harder to understand, okay, but if you've got a circle and you've got a chord, if a line bisects that chord, so if it splits that chord exactly in half, then you know that it must be a diameter. Okay, it must go through the center of the circle. So if you've got a chord, I'll just say that again. If you've got, my circles are terrible, but hopefully you get the idea. If you've got a chord, if you've got a line that splits the chord, then that must be a diameter of the circle. Okay, it's important. So you've got a chord BE. It's split in half. Okay, it's a perpendicular bisector. So you know that this must be a diameter. Now, therefore, what you can say is, well, we're trying to work out this angle here. Well, if that's 90, that must be 90. Now, I need to work out this smaller angle here. Now, if this is a diameter, you know that the angles in a semicircle add up to 90, or the angle in a semicircle is 90. So if that's 61, that must be 29. And if that's 90, you can just add those together. So 90 add 29 is 119. 180 subtract the answer. This one must be 61. Okay. The next one. So if you have one that looks like an arrowhead, so you've got your center here, you've got the top angle, and then you've almost got this angle here. This angle is always twice the angle at the circumference. So the angle at the center is twice that at the circumference. Now you've got to imagine that these points here, so I'm just going to highlight them, these points here could move around wherever. So if these two remain fixed here, I could say, okay, well, I could draw it up here. That angle is still A. But what happens if what happens if instead of that, I rub that out, otherwise it would get a bit too complicated for you to be able to see it. If I said, okay, right, well, these two are going to stay exactly the same. What done here? Okay, if I said, well, these 2 points are going to remain in the same place, but actually this point, I'm going to drag it right down here so that it's there. That angle is still, believe it or not, A. So you've got to imagine that these points can move around. That is the angle at the circumference. That's the angle at the center. That is always double that. So for example, here, if that's 250 degrees, this angle here, you know that A must equal 110 degrees because angles around a point are 360. Now you know that this angle here is double this one. So if this is 110, B must be 55. Now this one, again, these points have just been moved up. They were probably here. That would have made it look like an arrow, but they've just been moved up. Now if that's 99, this one's just double it. So 99 times 2 is going to be 198. And this one, similar to the one that I was talking about up here, they've just moved that point around. So if that angle's 80, this one is just half of that, which is 40. So they could have drawn it up here. But they've just moved that point around, which is why it looks a bit odd. So you've got to imagine these points are fluid. They've moved that arrowhead around, but the theorem still is exactly the same. Copy those down, copy the examples as well, because these ones look, when they look like an arrow, it's a lot easier than when they try to move it around to confuse you. So copy those different variations down. Okay, now this one I find personally okay, because to me it looks like a bit of a bow tie. Now, if you've got a bow tie, the reason here is angles in the same segment are equal. If you've got one that looks like a bow tie, what I'm saying is if that's X, that must be X. And if that's Y, that must be Y. So if you've got a bow tie, these top ones are the same, these bottom ones are the same. You've got that here. So if this is 39, this one's 39. And if that's 86, angles in a triangle add up to 180. So 39 add 86, subtract that from 180. This top angle is going to be 55. So this top angle is 55. That one should be okay. But the reason is angles in the same segment are equal. This one again is fairly self-explanatory. If you have a circle and you have a quadrilateral, so a four-sided shape that touches all of the points of the circle, so the circumference of the circle, the opposite angles add up to 180. So if this one's 111, if you do 180 subtract 111, you've got 69 degrees. And then if this one's at 84, so 180 subtract 84, this one is 96 degrees. So again, that one's fairly straightforward. The opposite angles in a cyclic quadrilateral add up to 180. I think we've got two more, okay? So I know that there's an awful lot of information. Hopefully you've got your notes written down in your book so you can refer back to these. Now, we know that if this is the center, this is the radius, okay? And these are tangents. So this is a tangent. Well, you know that that must be 90 and that must be 90 because a radius and a tangent meet at 90 degrees. This is just a 1, 2, 3, 4-sided shape. So if that's 50, that's 90, and that's 90, you can just take that all away from 360. So you can say that x is equal to 130 degrees. Okay. Now, the rule here is two tangents to a circle drawn from a single point are the same length. Okay, so these are the same length. And actually, if I'd drawn this down here, it would have been two congruent triangles. That length is the same. We've got the radius is the same. So if I just say that's 4 lines, that's 4 lines. These two lengths are the same. These two lengths are the same. And they share the middle length. So it's two congruent triangles. It's side to side. They've all got exactly the same sides, which is making them congruent triangles. Okay, the last one. Okay, the last one is easier if I explain this. So this is quite complicated. If you've got your tangent like so, and you've got a chord, this angle here, okay, let's call that B. That angle, this is what we call in here, this is called the alternate segment. It's the opposite segment. Okay, so it's the alternate segment. Now, if I rub that out, this is the best way to explain it. So if that angle is B, if I go from the same point, and I just draw a triangle out, so I draw that triangle absolutely anywhere that joins back with that chord, that must be B. If I draw another triangle out, so imagine that touches the edge, that must be B. So it's basically from your chord here, any triangle that is made from both points of that must equal B. So you've got here, if that's A, any triangle, that's A. And then in reverse, if that's B, that's B. But also, if I draw this triangle out, that angle is also B. If I drew this triangle out, that is also B. Okay, and that is the alternate segment theorem. So that's all you need to write. If you've ever got one of these questions, that's 46. So that one must be 46. Why? Alternate segment theorem. Okay, that's 114. Angles on a straight line are going to tell you that one is 66. So this angle here must be 66. It's alternate segment theorem. Have I done that right? 180 subtract 114 is 66. Yeah, so we've got alternate segment theorem in both examples. Now I know that I've gone through loads of different rules there. You just need to spend some time today potentially creating flashcards, going through them, quizzing yourself. You need to remember all of these. The exercise that I'm going to give you next is lots of questions jumbled up. So see which ones, refer back to the notes in your book, see which ones you can do, and remember to write the reasons for all of the answers. So rather than worrying about all the different letters, just try and find as many angles as you can on that diagram. So find as many angles as you can, and the answer will just pop out. Here are some more questions. And then here are the answers. So go back and work out where you made a mistake if you did so. Okay, GCSE question. Okay, now if we're going to go through this, so A, B, C, D are points on the circumference. Okay, fine. AC is a diameter. Now that tells me that this angle here must be 90. So then I'm just going to say, well, if that's 25 and that's 90, I'm going to subtract that away from 180, and that's going to give me this angle here, which is 65. Now I can see there's a bow tie in here. So if that's 65, that one must be 65. Are there any other angles? Well, if that's 100, this one must be 100. And then if that's 100, this one must be 80. And if that's 65 and that's 80, if I subtract that away from 180, this one is going to be 35. And if that's 90, that one's going to be 55. And then I've got my bigger triangle here. So if that's 65 and that's 55, this total angle here must be 60. So if that's 25, that one must be 35. This one must also be 80. And if I've done it correctly, 65 add 35 add 80 is going to give me 180. So I've just worked out all of the angles there. And then what does it say? Work out the angle DAC. Well, I've already done it. Okay, so don't necessarily think of just trying to find the answer. Just try and find as many angles as you can, going around in a circle, and then you will just find the answer. Okay, what I should have put is that you needed to write your reasons. So for all of these, make sure you write your reasons. Okay, so make sure you write your reasons. Okay, well, this one, what is the main theorem you would use if you had to find x? Now, this, even though it doesn't look necessarily like it is, this one is a cyclic quadrilateral. It's going to be D. What is the reason here? Okay, well, this one, it goes through the center. Angles in a semicircle are 90. So this one, the angle in a semicircle is 90, because then if you've got those two angles, you'll be able to work out what x is. The last one. Okay, a tangent and a radius meet at 90 degrees. So a tangent is perpendicular to a radius. Okay, well done for listening. Go away, revise those facts. You need to learn them off by heart, and the more you are fluent at them, the easier these questions do become.